Thank you. It's a pleasure to be here. I've spoken here before in the old days. After sailing around the world, I come and maybe some of you have heard me and seen my videos and stuff, but I've done lots of sailing. I've actually broken a mast in every ocean on the earth. I've broken 7 masts, 8 rudders, and we were test pilots in the old days. We were building the first ultralight boats, the tallest masts we could build, the biggest sails we could put on, new carbon fiber, new materials. We were looking for storms to see how fast we could go, and we pushed the envelope and we found the edge. But I've sailed many, many times, years and years, with Kiwis and New Zealanders who are the best sailors in the world. Sorry, Americans. I've sailed around the world twice with them, I know. They taught me a saying: you break it, mate, you fix it. No whinging. So 7 masts, 8 rudders all over the world gone. We never once called for help. We never once got a tow in. We sat down, we fixed it, and we sailed in. And that's what I learned from the Kiwis. So I'm going to talk about weather, and this is a class that I teach. I taught many years at Orange Coast College Sailing Center. And it's very important, whether you're a sailor or a powerboater, just to know weather is very important. Whether you're the captain or whether you're just on the boat, you need to know the weather. Decide, should I really go if it's rough? And I'm going to be talking, I do like a 6-hour talk in 2 hours, so lots and lots of information. That's why I brought my books, because you don't need to take notes. Everything that I'm going to talk about is in my books, so you can go back and read them, especially like where you go to put in codes to get all the different weather maps and stuff. It's all in the book. Okay? Do you want to race Trans back to Hawaii? This is me on Silver Bullet, Santa Cruz 70, 1993. We were first to Hawaii, first to finish, first in class, first overall. We got into Hawaii, went into all Hawaii. It's very rarely anybody gets all those 3. So we got into Hawaii, got a broom and stuck at the top of the mast, clean sweep in the Ala Yacht Harbor. Really fast boat. Our top speed was 30 knots. In those days, that was really fast. Do you want to go safely fishing? That's me catching an albacore on the way home from Hawaii. I've come back 31 times. I love the trip back, because for me, it's a busman's holiday. You're racing, it's 24 hours a day, push, 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 no alcohol on board, and you're just going all out. To Hawaii, it was everything from 6 to 15 days over. But the trip back, instead of 15, 17 crew, we have 4. We fish, we stop and go swimming, we really enjoy each other. We have a happy hour in the afternoon, so it's good fun. I like the trip back. Do you want to go for a fun, safe sail with a few friends? Notice how many life jackets they're wearing. 0. Why do you need to know the weather before you leave the dock? Look at this little tiny boat here, and this is a huge squall. You need to know this is coming. All right, should you go or not? If bad weather is forecast, the best decision might be to not leave the dock. The responsibility of the skipper is to keep the crew and boat safe. Even if you're not the skipper, you have the ultimate responsibility to decide if you should go. Learning how to forecast weather will help you decide. So that's why everyone needs to learn weather. This is where it all started. Titanic, 1912, hit an iceberg and sank, lots of deaths. After the sinking of Titanic in 1912, there was a safety at sea conference. They felt there was a need not only to report ice, but to observe and warn weather. The World Meteorological Organization was founded. The world was divided into sectors, and different nations signed up for safety at sea to take in weather information to increase safety of life and property. All the countries in the world, except North Korea, are members of this now. The National Oceanic and Atmospheric Administration, NOAA, that's our member, and that's where we get most of our weather, and you're going to get most of your weather from there. Today, every maritime country in the world sends weather data from thousands of ships, sea buoys, weather balloons worldwide to all the other countries. The data is then used to generate weather models. Our basic model is the GFS, Global Forecast System from NOAA, but there's several others that are more high resolution, and I use a lot of them, and I'll talk about a lot of them. It's free. If you're racing, you cannot pay for weather while you're racing. It's against the rule. That's Rule 41. So anyone can get stuff from NOAA because it's all free. Everybody can get that kind of information. So NOAA is really important. Here's basic weather physics where it all starts. Weather is caused by the sun. Hot air rises, cold air sinks. Nature hates a vacuum, so when the hot air rises, it brings air in to fill that vacuum, and that's what causes wind. The air moves from high pressure into low pressure, creating wind. Here's what happens. Hot air rises, makes the vacuum, goes up. As it cools, the molecules come closer together, gets heavier, comes down, and it goes in and fills that vacuum. That is wind. That's where it all comes from. High and low pressure. There's two systems, high pressure systems and low pressure systems, that really affect our weather, especially if you're out there on the ocean. High pressure has cold air near the surface. The air is sinking, and the area has clear skies. It's usually good weather and you're in a high pressure area. The air is moving away from the high center and going out to find the low and move into the low. Low pressure, warm air is near the surface, and it's rising because it's light. And as it goes up, it cools, and it causes clouds and rain. And the strongest winds are near the center of a low pressure. Winds diminish as you move away from the low center. Those are real basic stuff. So here's a high and a low. Low pressure, warm air rising. And in the northern hemisphere, the air, as it rises, goes around counterclockwise and goes up. And then it leaves that vacuum. The air cools, comes down, and instead of counterclockwise, the high pressure, it's going clockwise and goes in and fills that low, and that's what causes the wind between the high and low. All right, this is a global circulation. It's really warm along the equator, intertropical convergence zone, or they call it the doldrums. I've been through it many, many times. It's no fun. Hot air rises, comes up, cools, wants to come down. It can't come right back down, so it goes north or it goes south, and it makes these subtropical high pressure zones. And that's what causes our highs in all of 4 oceans. And those, as the wind goes around, remember, clockwise, it causes the trade winds. So you have northeast trade winds in the northern hemisphere. Southern hemisphere is just the opposite, southeast trade winds. Each of the highs in each of the oceans actually spins around clockwise, 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 clockwise. They all have a high, and there's your trade winds. And those highs spinning around actually cause currents. So the currents in the Pacific Ocean go around clockwise. In the Atlantic Ocean, clockwise. Southern hemisphere, just the opposite. Counterclockwise, counterclockwise. And it causes the currents. So the currents in the ocean are caused by the high pressure systems. These are all important stuff. The best way to predict weather is to understand weather maps that you get through your computer, mostly from NOAA. For us, every 6 hours, the International Weather Services gather up globally all the data they can get, temperature, pressure, humidity, wind speed, and direction from all the weather stations, balloons, ships at sea, satellite data. They plug it all into supercomputers, and each country produces their own weather models. The various services all compare their models, then they sit down and they draw cartoons. They draw the weather maps. And that's what they send to us, and that's what we have to hope is right. So GRIB files, GRIB is a gridded binary file. It's a really highly compressed format. The weather services worldwide take all the data they get from weather stations, ships, balloons, and satellites, put in the supercomputers. The computers spit out these wind maps, and they're called GRIBs. These wind maps are highly compressed format because they can go quickly through radios and be put into a map, or they can go through satellite communication. And because they're so compressed, they go really quickly. You can't use the stuff you have on your computers at home when you get in the ocean. Sorry, you have to use different programs. The predict wind will do several days out. Now they can. It used to be 4 days was you could trust. Now you can trust 7 days. After that, I would say don't really trust it. But 7 days now with the NOAA stuff is really good. The GFS. You download the GRIB file, you put it in your computer, and then you open it up with a GRIB viewer, and they're free. So this is a GRIB file. This is what it looks like. These are all the wind barbs, and you'll learn about what they all mean, but if it has one big feather, it means the wind is going the direction of that arrow, and the feather is 10 knots. And this is 10 and a half barb, so this is 15. This is, see if we have any 20s here. But, yeah. Anyway, well, we're going to talk more about that later. But this is what all of the weather maps use. They don't use arrows. They use barbs because it's really easy to see. It's the direction that it's pointed, and this is how much wind there is, 10 knots. It's really easy to see. These human-generated maps get published as weather maps. Then the forecasters use the weather maps to write text narratives for the local weather forecasts. This is what you see on TV in the evening. They're using the same stuff. It's what you hear on the voice broadcasts on your VHF radio, and it gets updated every 6 hours, midnight, 6, 12, and 18 on UTC. That's in England. The weather on VHF gets updated about every 15 minutes on your radio, your VHF radio, because you're still getting this weather, but then they're adding in what's happening. They've got buoys out there, and they've got people on boats, so they're changing about every 15 minutes on the VHF radio. It's a good way to get weather if you have a VHF and you're in distance of one. All right, get weather easily on VHF radio. If you're within you have to be within, I'd say it might be good out with a good antenna out about 20 miles, but that's about it. Once you're out past Catalina, you can't get weather on VHF, or you're 20 miles past Catalina. You go to WX, you go from channel 16, you just hit the WX button, and then it takes you to weather, and you have 7 to 10 weather channels. We have 7 here in the Southern California. A lot of the areas in the United States have 10 channels. So you start at channel 1 and you listen, and then you move up to channel 2, 3, 4, 5, 6, 7. The loudest and clearest channel is the closest one to you. And so it's going to have the most exact weather. That's the one you want to listen to. And I have them all here. Here's our 7 channels. Weather number 1 is Los Angeles County. That's what you guys are going to use. 2 is San Diego. 3 is Santa Barbara. 4 is San Diego Marine. It's just for boats. 5 is Santa Ana, Orange County. 6 is Victorville. A lot of sailing out there. And 7, Oxnard and Ventura. Okay, air pressure is measured in isobars. Isobars are these lines that are all the same amount of pressure, and they draw these on all the maps. This is the number of millibars. Isobars are usually 4 millibars apart, and the closer the isobars are together, the more wind there is, and that's really important for you to know. And look at the maps and say, if the weather's, you have really tight isobars, either go there if you're racing, but don't go there if you're cruising. So it's really important you know that. You know you have this map, and you watch how close the isobars are together. Okay, the average air pressure worldwide is 10-12 millibars. Highs are generally above 10-12. Strong high is above 10-30. The North Pacific high is often up in the 10-30s. It's very strong high, one between here and Hawaii. Lows are generally below 10-11. A really strong low is 990 or below, and a Pacific hurricane could get down as low as 920. Typhoons, which are even stronger than anything we have, or hurricanes, can get down to 870, and they get 250-mile-an-hour winds. Just blow things apart. The bigger, the bigger the difference between the high pressure and the low pressure, the stronger the wind. The U.S. is the only country in the world that uses inches instead of millibars. So learn millibars, don't learn inches. Although on the TV they might say the weather is in inches, so whatever. You need, if you're sailing, you need isobars. This is an aneroid barometer, and it tells the pressure. It's one of the most important instruments you can have on your boat. It doesn't use any power. It tells you the pressure. It's a series of bellows that move in and out as the pressure goes up and down. If the pressure's going up, the weather's getting good. If the pressure's going down, the weather's deteriorating. This is one of my most important things, even though I have all of the computers, satellites and everything. This is my baby, and I keep a log with it. Just pass it around, take a look at it. That's a Weems and Plath. This is a good one. All right, so very important. Get one of these on your boat. They aren't that expensive. This is one of the best series. I think it was 75 bucks. The barometer, one of the most important weather tools you can have on the boat. No matter what the forecasts say should be happening, a barometer will tell you what is happening. You can plot your position on the weather map, look at your barometer, at the isobars. If they match, you can trust that weather map. If they don't match, don't trust the weather map. So this tells you if the weather is right or wrong. This can tell you how accurate their analysis is. If the pressure is going up, the weather's deteriorating. Pressure is going down, it's deteriorating. If it's going up, it's improving. And that's really important to just watch. And I keep a log, a weather log. Every time I come off watch, whoever comes off watch, they log in the barometer, the isobars, and we chart it. And they now have ones you can actually run on your laptop. This is a digital barometer, and it goes into your laptop, and you can actually track it for like 2 weeks out and just watch what the weather's doing, the isobars, because that is the basis of where the highs and lows are. All right, here's a surface analysis. This is what you get from NOAA, and it's got a lot of stuff on it, but you'll learn how to use it and see it. The low is the low pressure system. H is the high pressure system. This is our fronts. This is a cold front. If it has triangles, this is a warm front, cold front. This is called an occluded front. This is an occluded front. These little black dots up here, ice. Don't go up there. Because look, this is the date, April. They've got ice up in Alaska. It also tells you who the forecaster is. The date, this is for 1505. That's the time in Greenwich, and the date and the year. So you know when this is, and the forecaster, you get to know them all their different names. They have to put it up there. Some of them are good, some are not so good. So you learn which are the good ones. Wind close together, small isobars, big wind, big isobars, no wind. Okay, these are all the symbols, test chart symbols that you'd see on your weather maps. You can just go to NOAA symbols and test charts and just print this out and learn them all. Here's all of our barbs. It tells you if you have tropical depression or a hurricane, tells you the fronts. It really tells you a whole lot of stuff. It's good. You should learn these. This is a hurricane. All right, wind barbs. Wind barbs we use all the time, and we don't use arrows usually. This is 15 knots, and says the wind is from the west because it's going east. So it's west at 15 knots. This one, if you have a black triangle, that's 50 knots from the south. This is 50, 60, 75 knots from the southeast. This would be a hurricane. All right, and you have an information box that tells you everything. This is a warning box. They'll also have these little boxes Hurricane Lester. I was coming back from Hawaii. This was a few years ago. Because here's Hawaii, and here's the hurricane right there. Hurricane Lester, maximum winds 90 knots, gusts to 100 knots. And it tells you the stuff. It's on the maps, so you know what you're looking at. This is a 24-hour forecast. That your regular forecast is that day at one of those 4 times, so 0, 6, 12, or 18. 24 hours is what they think is going to happen in 24 hours. Here's what's going to happen. The low is going to move from here, the X over to here. Your high is going from here out here. This high is coming in here. So this is probably going to become a big North Pacific high out here. And you learn to know these and see what's going to happen in the future. So this is 24 hours from now. This is 48 hours, 2 days out. This is California. This is Japan. So you can see there are a couple of big storms out there, and they warn you, gale. Gale is over 34 to 40 knots is a gale. Look how close together some of the isobars are here. Got 40 knots of wind. So yeah, as they get close, you get big winds. A gale is a lot of wind, and that's I teach probably once or twice a month safety at sea seminars for U.S. sailing, and my job is talking about weather and when to change to storm jibs, storm trysails, how to do it, and that's if you haven't got one of my little sheets there, that's what it's all about. When to change sails, what to do to change sails. Get one later. They're free. And it's really important that you know what to do. So this is 48 hours out. This whole low is moving into the west coast here, probably up to Oregon, Washington. We'll talk more about that in a minute. This is 96 hours, so this is 4 days out. And you can see the same thing. You can follow them. Here's a developing gale. A lot of wind up north. Down here, not much at all. High pressure system. That's the North Pacific High. This is a wind wave forecast. Another one you can get. It tells you the barbs, that's the wind, 20 knots, 15 knots, but it also tells you how high the seas are, the wave and swells. So this is 9 foot, wind 15 out of the southeast. Here we have 10 knots, 6 foot. So this is the size of the seas, and then it also has the wind with you. So it's kind of a quick, easy one to use. And it'll tell you when it's the date and time that it will be there. Here's a tropical wind wave forecast. This is one that I use when I go to Mexico because it starts right about mid-Cabo and goes all the way down to Peru. And this is a swell, and this is the wind. You can't get the NOAA ones in Mexico, so you have to get this when you're in Mexico. I just came back from Puerto Vallarta. I delivered a 63-footer racing boat back, and we had real light winds, except one day, 33 knots of winds, 18-foot breaking seas coming into Cabo, so that really got us ready. This is the NOAA Buoy Center, which is a really good one to use, especially if you're not going to probably get this on your boat because it's got too much. You can't get big illustrations. It has to be really tight grid files. But before you go, you look at this, and if these are all the buoys offshore, and then you just click on one. And so I clicked on Tanner Bank off of San Diego, and it's out here. Here's San Diego. And it tells you right now they have 21.4 knots of wind. They've got 29-knot gusts. I don't know why they have inches there, but they tell you this is really good. So before you leave, you look at this, and you see what's going on out there, way out past Catalina, up Channel Islands, wherever. So it's a good one to have. And it's called NOAA Buoy Center. This is fronts. Cold fronts have a semicircle, and if they're colored, they're in red, but usually they're black and white. Triangles are cold front. Semicircles are warm front, And where these are pointed, that's the direction of the wind. So the wind's going here, here. Stationary front's just stuck. It's not cold or warm fronts. It's usually not, maybe just a little drizzle, not much. Occluded fronts, kind of the same thing, both cold and they're just kind of sitting there. Here is a cold and warm front. Whenever we get a cold front, and cold fronts will bring light rain, and they're the ones that come down and we get the little rain out here, and especially up above Point Conception. The wind always goes south. So if you see that wind heading south, you know a warm front is coming. And once it goes through, then we get the cold advanced air, and this is kind of light. You might get a little sprinkle. This one, the warm front, or the cold front, big winds, storms, lightning, thunder, and that's after this one clears out. That's why we get the big clearing norther, the westerlies that come in after the front comes through. And you know if this is happening that you're going to get big strong winds out of the west the next day. This is a warm front. Warm fronts, wind is behind the semicircles. Cool air is ahead of the front, so it's cool up here, and it's bringing in warm front, and that warm is making the water rise, and that's why you get rain. High clouds ahead of it. If you see the stratocirrus up there, cirrus clouds, the little wispy ones, that means there's a good chance that we have a warm front coming in. And then if it goes to a stratus, you know it's coming. I'll show you more later. But anyway, the clouds teach you a lot. The high clouds come in front of it. Then you have fog or steady rain as it passes, and lighter, steadier wind than the cold front. So this is kind of light wind, a little bit of rain, a little bit of mist, but not really crazy. Warm front, here it is. This is the stratus coming in. You can see it's bringing rain. You know, it gets dark and gray. Here it comes. But before that was the little wispy clouds up there, the cirrus. So learn your clouds. You can know so much by knowing your clouds. The cold front is behind the warm front. The triangles point in the direction of the wind, so it's coming in out of the west. They indicate a heavy cloud line, thunderstorms. The wind will shift from south to west as the front passes. Stronger and gustier wind than a warm front. This is cumulonimbus, the ones with the big anvil clouds. That means you've got storms coming, probably thunder and lightning. This is a real storm when you see that stuff, especially if you're up in the mountains. This is a warm front, just kind of light rain, not much wind. Light consistent rain, light wind. All right, let's talk a little bit about the jet stream. Jet stream is this river of air way up about 30,000 square feet, way up there. And it's moving really fast, and it's kind of bringing all the wind from west to east. It kind of controls all the wind in the northern hemisphere. There's also one in the southern hemisphere, and it's going the same way from west to east. It's just that all of the directions are opposite, clockwise instead of counterclockwise. The jet stream tells us a whole lot about what's going to happen in the future because it's faster. Wind. Air moves in 3 dimensions in the atmosphere. It's horizontally down here, right and left, but it's also vertical, and the wind up vertically is going up or down, and it's also moving really fast across. A surface weather map will tell you how the weather is moving down here, but the upper level map, which is called a 500 millibar chart, will tell us what the weather is doing aloft and what's going to be happening. So that tells you ahead of time. Because it's moving so fast, if we have a big low up there, that means it's ahead of a big low coming behind it. So whatever you see up at the 500 millibar chart, 2 or 3 days later, we're going to get it down here. That's why we use the 500 millibar chart. The weather in the upper atmosphere influences the weather at the surface. The jet stream is about 30,000 feet, and it's like a highway transporting the weather systems from west to east. 500 millibar charts show the weather at about 16 to 18,000 feet because there's more wind. If you get up in the jet stream, there's almost no wind. It's so high up. The best information about the future position and strength of highs and lows is from the 500 millibar chart. The zonal flow, straight east to west path of a jet stream is characteristic of a southerly weaker high. So if you have a really strong jet stream going across, you're probably going to have a good high pressure system between here and Hawaii. Here's one right here. This is a 500 millibar chart. This is not on the ground. Here's Hawaii. Here's LA. This black line is the jet stream. So you can see low pressure, low. Here's a little high up here, but most of your lows are just above the jet stream, and that's why they move across into Oregon, Washington, Canada, and don't come down here, because the jet stream keeps them up there. Satellites, another thing that we really use now, and it can really tell you how accurate your charts are. You can get these on your boat. They're black and white, and they're very quick. This is actually California, Hawaii. This looks like a storm right here, a low pressure system, because a high would be going this way. Watch, I'll show you. So here is a chart. This is a photo of this chart. And so you can see how accurate they are. This is that low system here, and there it is there. This is a front here, and you can see the front here. So the guys making these maps look at this, and they start filling in the isobars because they can kind of see where they are. But then they also have ships out here that are sending all of these. There's thousands of ships out there that are sending their weather information all the time. And they take that information and put it all in, put it in the computer, and draw these charts. So they're getting more and more accurate. They also do sea temperature. This one is colored, so it's a pretty big thing to run on your computer. You have to have in Marsat or something you do it. You can't do it on Iridium Go. But if I race Newport, Rhode Island to Bermuda a lot, the Bermuda race, and this is the key to winning the Bermuda race. The darkest color is the most current. This is like 5 or 6 knots of current going like this, and it gets up here, and you're going from, let's see, where are we? From like here over to here. It's right in here. So you get in this, and you play with these currents, and you can get 2 or 3 knots faster than the guys that are not in there. So this is really, really key to racing to Bermuda. Okay, this is how they make weather maps. They take their satellite photo, they get all the information. All of these yellow ships with a dot, these are ships calling in saying, this is our speed, this is the wind, direction, and they get hundreds of these. They put them in, they draw the isobars, because these guys are always also telling them not the wind direction, but the isobars they have, and so they're pretty accurate. They stick all that in the computer. Computer sends it out to us. All right, why do you need to know where the lows and highs are, the fronts? Say you're racing from here to Hawaii, or just from here out to Catalina. If there's a low in the middle there on your weather map, and you're going from here to there, the low is, remember, the wind is going counterclockwise. So if you're down here, you're going to be beating into these big waves, big wind. If you say, wait, let's go north, wind's behind you. You got your spinnaker up, you're running downwind. So that's a good reason you need to know the direction of the highs and lows and where they are. Now, just the opposite. Say a high's out there. This guy's going north of the high. Wind is against him. He's beating into the big waves and wind. This guy who goes south of the high, he's got the wind behind him, his spinnaker up, and he's going down fast. This is Transpac. That's why Transpac, all the races go south of the high. Get to know cloud types and what they mean. It's really important. I would study clouds. Just go online and clouds and get pictures of them and learn them, because they all have different meanings, and they tell you what's going to happen and what's coming. This is your big anvil top cumulonimbus. Don't even go in that. That's your storms, your lightning, thunder. Cirrus, it's just really light winds That means probably a cold front's coming in. Altostratus, cold front's coming in, it's going to rain. Cumulus, nice puffy clouds. So you get to know your clouds. This is a cirrus, wispy clouds. This means in a couple days we're probably going to get a little bit of rain. Something's coming down from the north. Altocumulus, when you see this start coming in, definitely we're going to get rain. It's on its way. Stratus, here it comes. This is all rain. It's happening. This is all a warm front. And then if it's this one comes in afterwards, this is your cumulonimbus. That's your cold front. And that's your thunder, lightning, big winds. Could get really nasty. Cumulus clouds, little cotton balls. That's nice weather. And this, when we're racing to Hawaii, we're out in the middle of the ocean. We finally get our spinnaker up. We're halfway across. You see these, you go, it's going to be nice the rest of the way to Hawaii. Although we get some squalls, but this is what you want to see this. This is good stuff. Sailing and squalls. There's a lot of squalls out there. A squall is when hot, warm water, as you get out in the middle of the ocean towards Hawaii, the water heats up. And it's really hot out there now. It evaporates, comes up, cools, makes rain. The rain, it gets heavy, it comes down, makes wind in front of it. And these are moving along at about 20 knots, going towards Hawaii from Canada, going around the high. And they can be dangerous. This last summer I brought a boat back from Hawaii, Raikapu 63. And I've been doing this 40 years across between here and Hawaii. Every year the water's gotten warmer. Every year there's more fishing nets out there. And it's not just plastic bottles, plastic bags, it's fishing nets. That's the junk out there. Every time now we have to dive in and cut it off for the keel and off the rudder. Every time I cross. And the water's warmer and warmer and warmer. This year I keep a log. The whole crew keeps a log. And we went back and counted the number of squalls. We had 120 squalls coming back from Hawaii in 14 days. So it's just so hot out there. Don't let anyone tell you there is no climate change. So this is a squall. The wind rises. It's moving this way, and it kind of dumps the wind down in front and makes a big wind in front of the squall, but it makes a big vacuum behind the squall. And then it's kind of in between, kind of in the middle. So what we do when we're racing, if you're a heavy boat, you just get out of there. You don't want to get stuck back here with no wind. This is usually 0, not 5. So you just kind of jibe away, get away from it, let the squall go by. It'll come back to trade winds, and then you go back on your course. If we're racing, we get out in front, put up a spinnaker, and we're going jibe, 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 jibe. But as soon as you feel water, as soon as you feel rain, jibe out on port, get away from it, because you get stuck here and you're dead. I was doing a Transpac. It's actually that one in 1993 on Silver Bullet. Pyewacket was next to us. That was Roy Disney's boat. I've sailed all over the world on Pyewacket, and I was Roy Disney Sr. And we were right next to each other. We were a little below them. They were a little to the north of us, but pretty even. And a big squall line came through, and we felt the rain. We jibed out away, let it go by. They stayed in front of it trying to make miles. Next morning we woke up and they did a roll call. We were 30 miles ahead of them. They got stuck back here, sitting, no wind, and we were doing 20 knots. In fact, I just talked, I'm real good friends with the Pyewacket guys, and their new boat is so fast. I said, what do you do about squalls? And they go, we don't even worry about squalls. We're faster than the squalls. We just go sail by them. They're doing 30 knots all the time. The boat is so fast. This is a Roy Jr. I sailed around the world with him and his dad, Europe and Vic Maui and Transpac and Mexico. And the boat is so fast, it's always on the wind. They don't have spinnakers, no spinnakers, because they're faster than the spinnaker. If they put a spinnaker, it just blows back against the mast. That's how fast they are. So they've got 3 headsails, 3 jibs, and a main, and no spinnakers on the boat. And it's the fastest boat on the West Coast now. It's faster than Rio 100 and everybody. It's just, they're breaking all the records. They're all my old buddies too. Okay, sailing in squalls. A squall is basically a downdraft created by wet, cold air sinking down through a cloud. Squalls build during the afternoon as pockets of warm wind rise into the cooler air above. Eventually, the air mass will be cool enough to begin falling, creating a downdraft. In the evening, when the temperature drops, the process accelerates, creating more substantial downdrafts. The biggest, strongest winds hit just before dawn. The squalls will typically dissipate at first light. Squalls move about 15 degrees to the right of the surface wind. Behind the squalls, wind is light and non-existent, especially near dawn. There's zero wind. Okay, squall tactics. If you're a heavy cruising boat, as the squall approaches, just jibe to port, stay on port right through the squall, let it go by, and once it's gone, the wind will fill back in and you just go back on your course. You just have to sail a little bit out of the way for a while. It's the quickest way out of squalls to avoid no wind behind the area. For light, fast boats like transpac boats, you just jibe back and forth in front of the squall using the increased wind as long as you can. When the squall starts passing you, you feel that rain, get out of there. Jibe to port, get away from the no wind area behind the squall, because then once it's moving along at about 20 knots, so once it's gone, it fills back in. You just go back on course. So feeling the rain is really important. There's so much information you're getting today, and now it's going to get even bigger and bigger as we get into how you get stuff on your boat. It's all in the book, and that's why I want you to get that book, because all of the codes, where you need to go, all of your, there's so much stuff on your cell phone. You can have so many different weather station and weather apps. So I'm going to talk about the ones I really like, and most of them are free, and I use them all the time, and we'll talk about why they're good here, but they don't work when you're on the ocean, because you don't have cell phone towers out there, and even your VHF only goes out about 20, 25 miles. Okay, hurricanes. Hurricanes are formed by hot water, and they are low, tropical low, and remember lows in the northern hemisphere spin counterclockwise. They start spinning, and they're in hot water, and they pick up energy from the hot water, and they get hotter and hotter and spin and spin and spin until eventually they're going hurricane force. So in the Atlantic Ocean and the U.S. Off Mexico, they're hurricanes. And the Atlantic ones start out by Africa, tropical depressions, storm warnings. They start out as a tropical depression. And when you look at your weather map or you're listening to the weather radio, if it's less than 35 knots, they say it's over 30 knots, they'll say, and it gets to near 35, they'll say it's a tropical depression. It's TD, they give it a number, TD 16. And so you start listening to it and you put it on your chart and put it in your log. And then as it keeps building, it becomes a tropical storm, TS, and they give it a name, like Carmen or Anita or whatever. And that's over 35 knots. When it gets to 64 knots, that's a hurricane. And 64 knots is in the Atlantic and the Pacific. It's the HRCN hurricane, and it's a black spiral. If it's a spiral that's not black, it's white in the center, it's a tropical storm. If it's black, it's a hurricane. So it's Hurricane Hugo. If you're in the Western Pacific, Japan, the Philippines, China, they have typhoons, and they get huge, huge typhoons. I actually delivered a boat over to Saipan, San Francisco, Micronesia, Saipan, and we got into Saipan, and a hurricane was coming. The boat was he was running something in Saipan, and I was teaching him and his wife how to sail. We sailed across the Pacific, and as soon as we got there, they said a hurricane or a typhoon is coming. So they hauled the boat out. They dug a big hole in the ground. They dropped the boat in the hole and tied it down. And that's what they did when the typhoons come through over there. So it's very different than here. Cyclones are in Australia, Indian Ocean cyclones. But they're all the same thing. They're tropical storm depression. This is how they build. The water spins around and sucks up the heat. It gets hotter and hotter, faster and faster and faster. The cold air goes out the top, and it keeps sucking up the hot water, and so it becomes a hurricane. And that's why they get just stronger and stronger as long as they're in hot water. And then as they get north, the water cools, and that's when the hurricanes die. They rarely get out to Hawaii. They do some, a few times, but they start out off Mexico, and then they die usually before they're to Hawaii. They start off Florida, Caribbean, and then they usually die by the time they get up, to Carolinas or Virginia. All right, here is a hurricane, and this is, if you're out there, you don't want to be there, but if one comes through, this is the hurricanes going up this black line, and wherever you on here, you want to be in this is called the navigable quadrant. You want to be in the lower southwest area, because this thing's going northeast and the wind's coming in from the north and the east, so this is the most dangerous area to be. If you are up here, you want to just get away as fast as you can when the thing starts coming, and if you're up here, get away as fast as you can. You don't want to go in the direction of it. So this is a quadrant, and it's really important to know this if you're out in the middle. You could be in the eye, there's no wind, but then you're going to get hit for it again. Okay, waves. Let's talk a little bit about waves. Waves are out there, big swells, big waves. Waves develop as a result of wind blowing for a duration over a distance. The stronger the wind and the longer the fetch, the higher the waves become. Ocean waves that move a long distance become deep ocean swells, and they're the ones that give us the good surfing waves off of here. Wind is always changing in strength and direction, starts forming ripples as it builds, chop, little bigger waves, and swells, and then big waves. Oceanographers forecast significant wave height, and you can get that on the radio. You can get that on your from NOAA. Yeah, it's something you need to watch, the significant wave height. It is the average of the largest 1/3 of all the waves. So if that keeps going up, you should get away from it if you can, or else run downwind with it. Whitecaps usually start at about 12 to 13 knots. You should get to know them. You should get to know all your wind strengths, and it's called the Beaufort scale, and we'll talk about that later. If you know your Beaufort scale, you know just by looking at the water and trees and whatever, when it's time to start getting rid of sail, when it's time to start reefing, by just watching the water. So you should really get to know the Beaufort scale. And I actually gave it to you in the sheet I gave you. Has the Beaufort scale on the second page. All right, these are rogue waves. They're really big waves, and they usually form from a wave meeting a wave meeting a wave, and they get bigger and bigger and bigger. And they used to say in the old days, the guys sailing and on ships out there would say, there were these huge rogue waves, and everybody said, that's baloney. There's no such thing. But now we have videos. And there are 100-foot breaking waves out in the middle of the ocean. And some just breaking right over big tankers. And they are there, but they're very, very rare, and you're not going to see them around here. They're in the middle of the ocean. Okay, onboard technology. Now this is going to start getting a little different. This is how you get all this information on your boat, and that's why you need my book, because it has all in there, all the codes you need and where to go and what to look for. Things change when you go offshore. You don't have fast broadband. You don't have your Wi-Fi. Your bandwidth is very narrow. Your data reception is very slow. So there's ways you can get weather, but it's completely different than on land. There's things you can get on board out there. Voice forecasts you can get on your radio. If you have a single sideband or a ham radio, you can get a voice forecast all the time. Text forecasts, you can get those. You need you need to be able to get emails to get the text forecasts. Weather faxes, there still are weather fax machines out there that print out the weather maps, and you can get those. They're kind of going away because there's so much better stuff through the satellites. Weather images, there's satellite, radar, ocean currents. Grid files those are telling you the wind. They just show you all the wind for the next several days, and they're very quick. They come right through very fast on your laptop. And then buoy data, you can get that out there also. You don't get the nice picture and the colors and stuff, but you get actually the name of the buoy and the wind speed and direction. Okay, you can use your smartphone around here, and it's a great way to look for weather. You can use your cell phone for weather, GPS, chart plotter, weather radar, AIS. It's all on there. Pretty much everything electronic on the boat, but you must be in range of a cell phone tower, which is line of sight. And typical cell phone only transmit at 1/3 watt. They are not very powerful. That's why you need a cell tower nearby. They're only good for about 5 miles. A booster amplifier will help. You can put an antenna up to increase the range and the wattage up to about 3 watts, and you can get your cell phone will work out about 15 to 20 miles if you have an external antenna. Once you're beyond that, you're not going to get it. So the antenna cable can't be too long. It loses too much signal. About the first spreader is about as good as you can get. And if you're going from here to Catalina, you're fine. But once you get past Catalina or you're in Mexico, you're not going to get very much cell phone at all. All right, this is smartphone apps. There's a lot of them. It has a limited range, only about 1/3 knot. With a booster, about 3 watts. Watts, not. External antenna, you can go out 15 to 20 miles. There's many marine weather apps out there. There's a lot of internet sites. NOAA, you can get on has its sites. Weather buoy weather's good. You can check what's happening in all the buoys. I use SailFlow a lot. I use Predict Wind. I use Windy. It used to be Windy TY, but now it's just Windy. And Wind Finder. Those are all good things. In my book, I have lists of a lot. This is Windy. I use Windy all the time, and it's quite accurate. This was, probably says where's Monday the 11th, and I think this was the 11th of April. We had big winds, and there are 26 knots. And this just shows up on your cell phone, and you can play around with it. You can go in and out. You can go wherever you want and get the weather, the direction, the wind. So it's a really good one. And it has a bunch of different models. This is the GFS, but this is a European model, which sometimes is more accurate. HRR is a higher resolution. It has the wind barbs a lot closer. I took the wind barbs off of this. I just use the color instead, but you can get it with wind barbs also. And then it has NAM and ICON, I think. But it's really fun to get this one. I would get it, play with it, and learn it, because I use it all the time. Whenever I'm going out in the morning, I get up, I put this on, what's going to happen for the next 12 hours? And it's quite accurate. So
it goes out a whole week?
It'll go out 7 days, yeah. Wow. Except HRR is so fine. The arrows are only like a 1/4 mile apart, and it only goes out 17 hours. And NAM goes out 2.5 days, I think. But the rest of them, the GFS and the European model, they go out, I think they'll go out 14 days. But on this, 7 days, yeah. Is that 7? It might be 10. Looks like it's 10. But you can trust it out 7. I wouldn't go beyond 7. Okay, this is SailFlow. SailFlow is another one. These are, gives you the wind, but then it also, these are actual numbers that are happening when you turn this on. This is right now. That's your wind right now. It's not like this morning. It's not like yesterday. This is today. Someone is recording this. It's in a machine. And so you know where the wind is and where it is all the time with this one. So I use this one a lot, SailFlow. I think they have a free one. I think the one I have costs $2 a month or something, so I use it's a little bit better. This is Predict Wind. This is a one that has really pretty accurate wind speed, and 30 knots. So this was just before this last Ensenada race. They had big winds offshore, 30 knots. And this also does expedition routing. It does routing. I can show you. This is the routing. You put in you have to have your boat's polars. So how fast does it go at 10 knots with the wind at 90 degrees, and you have to have a polar chart, which usually your sailmaker can make that for you. But you stick this in, and then you say, I want to go. You just click here, start, and finish, and it works out 4 different routes. And you decide which one you think is the fastest. I think I would go the yellow route myself. But then you run it, and it goes like by hour by hour by hour by hour. And by the time you get here, these might be faster than this. So it's changing all the way down. And it's looking ahead like 7 days. This is expedition routing, which I use all the time. It's from New Zealand. Nick White, he's an old friend of mine, and it's very accurate. This is one from, this was Pacific Cup, San Francisco to Kaneohe Bay on Oahu, and it told us this is what we should do to get the best wind. You'd think, oh, let's just go like this, but turns out when you're about halfway across, there's no wind here at all. And so you got to get up and get into the wind. But anyway, it's fun. I teach this also, expedition weather routing. Okay, now to get stuff on your boat, the best thing to do is get sail mail, which is put on by a sail mail group, Stan Honey and guys up in San Francisco. Stan's a pretty smart guy. He's the guy that invented and built the yellow football 10-yard line. He developed that. He developed basically GPS for cars before it was ever in any cars. He did it for trucks. He developed this. He's also won pretty much every race in the world. A really, really smart guy. A really nice guy, too. Anyway, this is sail mail. Sail mail is an efficient email and data transport protocol for use over limited bandwidth and slow transfer. You can use it with a single sideband, ham radio, with a Pactor modem, or you can use it with satellites, Iridium, Globalstar, or Inmarsat satellite. You can, it runs 21 stations all over the world, and it sends you emails. This is not weather, this is emails. And so you can email people, they email you, but you use them to get all of your weather gribs in sail mail. It has to come in email. You can't just turn it on and get windy out in the middle of the ocean. Okay? So if you have a ham license, you can do it with WinLink, which is free, and you can get sail docs on that. The only thing is, if you're using a ham radio, you can't ever do any business or finance on it. That's just part of ham radios. I have a ham, and I use it a lot when I'm delivering and cruising. The email through the radio is very slow. It's better to go through satellites, and now the satellite prices are starting to come down pretty good. You can't send large graphics or photos. They're just too big. It'd take you an hour to get one little photo through, because that's how slow all the data is. So text and grid files are fine because they're fast and they get on really quickly, and they come in email. You stick it into fax viewer, and it comes up with your grid. SailMail is a nonprofit association of yacht owners that operates and maintains an email communication systems for use by its members. SailMail supports email communications using single sideband and internet, in all the oceans of the world. Sail mail can be transferred by Iridium, Inmarsat, VSAT, the Globalstar, Wi-Fi, cell phones, or sail mail. Sail mail's own worldwide network of SSB Pecto radio. That's a whole other thing, but it's in the book. Yearly membership's $275, but it's worth it for me. But I'm going to, you actually don't have to have this. That's to get all your emails. I'm going to show you how, and it's in my book. You can do it without, you can get your sail docs, which is your weather charts, without using sail mail. You just go to saildocs.com. But if you want to get it, this is in here, it's in the book. Just go read that and you'll learn about it. Sail Docs it's a weather service run by Sail Mail, but it's free. Even if you're not a member of Sail Mail, they do it for every sailor in the world, so it's free. So you go to saildocs.com, but it has to be an email, and get the instructions on how to ask for weather products. The GRIBs are from NOAA. Sail Mail takes huge weather files, simplifies them for your area, and they can be sent in small files that quickly go over your radio or satellite phone. This is what you do. You go to Sail Docs. This is how you get email weather from Sail Docs, which is Sail Mail weather. Query at saildocs.com. That's what you're sending email to. Sail Docs simplifies the process of obtaining weather maps via email. Here's how you do it. To retrieve a weather map, send an email to query at saildocs.com. And now that's going into Sail Docs, their weather program. You have to put in a subject line. I put WX weather, but if you don't put in the subject line, they won't send an email. No. So you just put in anything. You can say, duh. But I just put WX. And then you ask for the map that you want with its code. And so, like, I want the map of today's weather map for Southern California, or it might be 24-hour. So I write send pyba90.tif, and then I send that. You'll get a reply, which you open, and it's an email that you put into your fax viewer, and your view fax is free. If you just go on, and they will get you a view fax. It will line up your grid file, and you're going to see all the wind. So this is all in the book. So all of these codes of every one of the maps I've gotten in that book for you. So you can just go in and try them all out and get the email back and put it into your fax viewer, view fax. Okay, getting a grid file from Sail Docs. If you're not using a routing program, you need to download a grid viewer or use a routing program. Sail Docs has a free grid viewer called View Fax. So you just go into View Fax, download it. It gives you this little thing you stick your email in. For Sail Docs, go to www.saildocs and grib info. To request a grib, send an email at query@saildocs.com. Subject anything, WX is what I use. And then you send, and this tells you, I want the weather in this square. And so you need to know where you are and how big, and it needs to be a big square. So I want it from 20 north to 35 north. So that's like from Mexico up above, well, almost to San Francisco. 100 west, which is, inland like, I don't know, Victorville or somewhere, up to 170 west, which was out past Hawaii. So by just sticking in this, I have the whole northeast Pacific Ocean. And it's going to send me a grid file. And then I say I want tutu every 2 degrees. I want it for 24 hours, 48 hours, 72 hours, 96, 120. And then / I want it for pressure and wind. And so you open the email, download it to Windows, you move the file into your grid viewer, and it's going to give you the whole map of the North Pacific Ocean, and with all the wind speed, everything. for the next, this is 120, this is out like 6 days. So you just got to play with it, and that's why it's in your book. Read the book and try it at home. Home, things are fast. It's not like on a boat. Okay, so to sign up for a 14-day subscription, and this is what I use when I'm out on the ocean, you kind of do the same thing. You go to query@saildocs.com, you put in the subject, WX, and then I say sub, I want a subscription, SUB, and I want GFS, and I want that same thing, 20 north to 60 north, 160 to 120, and every day for 14 days, it will send it into my email box. So it's already there. I don't have to get on the radio. I don't have to do anything. I just open up my email. That's why it's nice to have SailMail, because all your email goes in there. Every day you just open it up. You don't have to call or write or anything. It's really nice. I'm a believer in SailMail. Okay. Satellite communication. Now we're talking about getting communication on your boat when you can't have your cell phone, you don't have your Wi-Fi. So there's a few ways you can get it. Sirius XM radio, satellite radio, like they have music and stuff, they actually have a good weather that they will send you down. It costs, but it's actually a good weather charts. It's one way. You can't contact them. They just send it to you every day. Barren weather is another one. A lot of the airplanes use that, but it's pretty expensive. Two-way communications are when you talk and they talk, and the little handheld ones are Iridium, Globalstar, and iSat phone. There's 3 of them mainly. Iridium is the one most of us use because they have the best satellite system. They have 47 satellites up there, and they all talk to each other. So you can always get through on Iridium whether you're talking or getting data, and it's real fast. So I would get an Iridium phone rather than the other ones. Permanently mounted units, Iridium Go is a little tiny thing, and you can't talk on it like you can on an Iridium phone, but it gets all the data. It'll get you all your emails. It'll get you all of your weather maps, all your faxes and everything, and it's much cheaper. Inmarsat, those are the domes you see on the back of boats. Those are fast, and they're expensive to buy, and they're fairly expensive to use, but they're really quick. And so a lot of the boats I sail on are very wealthy owners, so they don't care. They just go, do get the best. So I do. So Fleet Broadband, that's the Inmarsat, and VSAT, that's the big, huge domes you see on the really big power boats and on the cruise ships. And that is for people that go 24 hours a day. People are talking on the phone, business, people on the boat talking home and stuff. Very expensive to put in, but very cheap once you start talking. We'll talk about that in a second. This is an Iridium handheld phone. This is a 9795. It costs $1,200, but you can rent it for a month for $100. So like if you're going to Hawaii or Mexico, you can rent one for $100, and you can just get a month's worth of data, and it won't cost you hardly anything. Satellites can talk to each other. We use these to talk and pass data. It costs about $1.30 a minute, so it's not cheap. You got to do stuff really fast. For data, you need a dock. This is in a dock. So this you take out, and it has to be up talking to a satellite. So you take it out and go on deck, and you can talk, call home. But if you want to get data, it has to come back in here, and it gets it through an antenna, and then back in here, and it brings all that data, all your grid files and stuff. So for data, you need a dock and an external antenna. Iridium is the most cost-effective and reliable handheld option. This is Iridium Go. It's a fixed receiver. It only gets data, but it is also a Wi-Fi hotspot, so you can turn this on and talk on your cell phone. It can take up to 5 cell phones, but you don't want them to talk very long because it is fairly expensive if you start talking. But the data is really quick, and this only costs about $600. And it's this big. It's tiny. I've used a lot of these Iridium Go. They're good. Okay, this is a fleet broadband here. This is a Sailor Cobham. This is a boat I just brought back from Puerto Vallarta, Ryco Pew 63, good energy, and brought it back from Hawaii. Really nice system, really clean boat. This is the VSAT. These are the big ones. Very expensive. It costs a couple $100,000, but if you're a cruise ship, I guess it doesn't matter. Okay, this is kind of to tell you about the costs. If you get a single sideband and pack door, to get it installed, it costs about $3,500 for the radio and the equipment. The installation is about $3,000, so to do that, it's going to be about $6,500. But they're good for cruising because you can talk. It's all free. You can talk anytime to all the other boats around you and stuff. Iridium dock is about $3,500 once you buy it, and the antenna and the dock. Installation is only about $1,000, so it's cheaper. It's about $4,500 for Iridium, but you can also rent it for $100 for a month, or you just have to get an Iridium account, and they're everything from like $50 to a month to $1,000 a month, depending on how much you're going to talk. Fleet broadband, that's like this is $7,000, that to enter, so about $9,500. The fleet broadband 250 is about $14,000. VSAT small one is about $20,000, and mini VSAT's $36,000. This is the ones they have on the ships. I don't think you want that. Okay, things to consider. Single sideband email, moderately high equipment install costs. So single sideband radio, if you have a single sideband, then it's not that bad to do that. Low usage costs, it's very cheap. It doesn't cost you really anything to talk. And it favors long-term users who are out going around the world. You're going to Hawaii, you're going to Mexico, you're out there and you just want to talk to all your boats around you and stuff. This is a good one, single sideband. Sat phones are initial lower equipment costs, simpler. It's higher data costs, $1.30 a minute. It favors short-term users. That's why it's kind of smart to just rent one for a month and then get a card for a month, and you can talk all you want. Fixed satellite terminals, these are your big ones, VSAT. It's higher equipment costs, lower data costs. Where this Iridium is $1.09 a minute, I think theirs is 9 cents a minute for the guy on the ship and stuff. So it's longer term and high volume users. So these are the business ones. Now here's another option, is the Garmin inReach. And I think I brought mine with me. I use this. This is a tracker. It's a Garmin inReach Explorer tracker. $449. I think when I bought it was like $350, but it's gone up. It actually tracks your boat. It talks through the antenna up to a satellite. They have their own satellites, and you just put in, when you set it up, you say, I want you to send my position every 10 minutes if you're going to Catalina. I do every 6 hours, going to Hawaii. And it sends it up there, and they send it down into everyone in the world's computers. And you can also send messages on it. It has a little button, SOS. Hit that. It sends up SOS, your latitude, longitude, to Coast Guard, to everyone in the world. And this is it. And it costs you $400. You do have to get a plan, but that's like $14 a month or something. And they have a little tiny one now. The new one, it fits inside your hand. It's about that big. And it does the same thing. And they're about the same price, maybe $350. And some of the guys that I sail with have one of these, and they have it on their life vest. So if they go in the water, here I am. It just sends their everything to the Coast Guard in the water. So it's not a bad thing to have. Now this is me coming back from Hawaii. John Jourdane. I have a site on inReach. It's garmininreach.share. John Jourdane. Anyone in the world can just go on that site, click John Jourdane, and they're going to see where I am. You'll notice here we went, this is like every 6 hours, I'm giving them this. Uh-oh, we learned the hard way, you have to charge it. So we got out here and we didn't know what was happening because we were just sailing, but we got a phone call, email actually, and they said, you've sunk, you're not on the tracker. So I went down and looked at it and it was out of charge. So what I do now is I stick it on the stern pulpit, I charge it all up, stick it on tape on the stern pulpit because that's to talk to the satellites, and then I take 2 wires from the stern running light, just 12 volt, and I run it into it, and so every night it charges up when the light's on. In the day, the lights go off, and it worked the rest of the way, all the way back. And then after that, I took a boat up to San Francisco. And this is what the people at home get to see. And so they really like it. They get to track you. And here's, this is it. You can send quick, real fast little things. I'm checking in, everything okay. I'm starting my hike. This is a hiker doing it. I'm stopping here for the night. So you just do it in your cell phone. Your cell phone talks to it, or your laptop. You go to your site and you just type this in, and it sends it off from the boat to everyone who goes on your site. So it's kind of cool. Let's see, the new inReach devices let you exchange text messages with any cell phone number or email address anywhere, using GPS to track and share your journey's progress. You can also post social media or even communicate with inReach, and it's like it's free almost. It costs $14.95 a month to get all that, and so it's well worth it. And you use it for a month, come home, and you just shut it down. So it doesn't cost you anything. So this is something that I would think about getting. A lot of my friends use them now. All right. Prepare ahead of time. Use your home computer to sort through all the weather products. It's fast and it's free. Make a prioritized list of the products you will need and can afford to download. So you want to practice before you get out there. Get comfortable with the data you're going to use before you get out there, and the conditions are much more difficult. Too much information can be as bad as too little. You want you want to know the fastest, quickest weather charts you can get, and so it doesn't cost you a lot of money, but it also is just what you need and doesn't take too long. Where to start? Understand the current weather situation. Get the latest surface analysis and satellite images. Start with the synoptic weather. Synoptic weather is the whole Pacific Ocean. So look at the weather of that. What are the dominant features, highs, lows, fronts? What's going on? Where are they moving? Move to mesoscale. Mesoscale is like 1 to 200 miles out. It's out past all the Channel Islands. Get the local wind buoy observations. Use those. This is before you leave. Make your own observations and notes. What's the wind strength and direction? What type of clouds do you see? What's the barometer pressure and the trend? Is it going up? Is it going down? Look at the forecast charts and check the upper level 500 millibar charts. What's going to happen in the future? Getting the data on board. There's so much weather data available. You have to dig through the possible information ahead of time. There are literally thousands of weather sites out there. So you have to practice and learn the ones that work for you. And that's why my book will help you, because I've done all that. And it'll tell you where to look. Make a list of what you will use. Make a list of the weather maps, the grids, and look at the weather file sizes. You don't want real big weather files. You want small ones, so it comes through fast. Copy the URLs and put them into your computer. Try obtaining the charts and grids on board to see how long it takes to download them. This will help you when you decide which charts to use. You don't want fancy charts. You want just quick grid files. Nothing fancy. Coastal warnings. Just one last thing. I want to talk a little bit about Beaufort scale and small craft warnings. Small craft warnings are 18 to 33 knots, and you get a red flag, at the harbor office. A gale, or one red light. A gale is 34 to 37 knots. By then, you should be gotten rid of your jib, furled it up, gotten putting up your storm jib, got a reef in your main or 2 reefs in your main, or put on a storm trysail. 48 to 63 knots, now you're going with just a storm trysail, fore-reaching. Hurricane 64 plus, you don't want to be in that, but I have been. You're just trying to save yourself, put out drogues, slow your boat down, just have up a storm trysail and fore-reach, which means you're going about 45 degrees up a wave, 45 degrees down a wave, and you're just kind of trying to keep the boat from turning over. Okay, and then this is small craft warning, gale warning, 2 flags, storm warning, black center, hurricane 2, red and black. Now, the Beaufort scale, this is what the whole world uses, not so much Americans, but it is the best way to learn about sail and which sails you should have up and what you should be doing. It's a wind scale used internationally. It goes from force 0 to force 12. Get to know each force, what it looks like, and you'll learn when to know, when do I furl up my jib, when do I furl up my main, when do I drop to different sails, when do I put in reefs, when do I put up the storm jib, when do I put up the storm trysail. Learn to know when to reduce and add sails. Force 0 is calm, force 12 is a hurricane. So here's force 0. Now I've taken most of these shots, so this is off of Cabo, this is racing down to Mexico. So what do? You just sit, wait for the wind to come up. Force 1, this is me in the old days on Blondie. No, this was on I forget. Anyway, force 1, 1 to 3 knots. You're just starting to get a little heel in the boat. This is me on Blondie, force 2, 4 to 6 knots. Starting to get a little bit of ripples in the water. Force 3, 7 to 10 knots. You're getting some heel on the boat. That's Phil Ramming and Dave Ullman. We're racing to Hawaii in the start. This is force 4, 11 to 16 knots. This is off of Diamond Head. We're racing the Clipper Cup on, this was Crazy Horse. This is force 5, 17 to 21 knots. This is Tower. We're racing Transpac. And you can see we're starting to move along at a good speed. Force 6, 22 to 27 knots. This is crossing the Atlantic on Ondine. Starting to get big waves. This is an 82-foot boat. This is force 7, 28 to 33 knots. We're actually coming back from Hawaii, and this is almost in a gale. Force 8 is a gale, 34 to 40 knots. This is us racing Whitbread around the world race. We're down in the Southern Ocean near Antarctica, and we notice we have a spinnaker up, 34 to 40 knots. That's not smart, but these are Kiwis. Let's go, mate. We hit, our top speed was 32 knots, so fast. And that's an 82-foot catch. This is force 9, 41 to 47 knots. We're down near Antarctica. This is actually, one of my books is icebergs port and starboard. We're kind of slaloming our way through icebergs. You can tell it's pretty cold down there. We're right by Antarctica. There are icebergs around. This is force 10, 48 to 55 knots. This is a Sydney Hobart race. Notice all he has up, we're running off, and this is just a storm jib, a little tiny storm jib to keep the boat. You don't want to go bare poles. Bare poles, you roll over. I learned that the hard way. Always be proactive. Always have some sails up, and so you can be in charge. This is force 11, Sydney Hobart, 56 to 63 knots. Just a tiny little storm trysail up, and they're fore-reaching. You're going at about 45-degree angle to the waves.
How'd you get that picture?
Helicopter. This is force 12, 64 plus knots. That is an 800-foot tanker, and the wave broke over the whole tanker. You don't want to be out there then. Okay, a final note. Take a weather course. Read my book. Learn where and how to get the latest weather forecasts on board. Get and use a barometer. That's one of the most important things you can have on your boat. Keep a weather log. Every time someone comes off a watch or you come off a watch, keep a log. What's the wind doing? What's the barometer doing? What are the sea state? What are the clouds? Learn the clouds and what they mean for your approaching weather. Learn and use the Beaufort wind scale so you know when to go down to smaller and smaller sails. And that's all, folks. Yeah, we'll do questions if anybody has questions. Yeah.
This might be a completely different class. Fog.
Yes.
So, without getting into it deeply, I heard once that if your dew point and your temperature are close, you can expect fog.
Mm-hmm.
But quite often, I've seen tons of fog out there, and I'll look on the NOAA website, and it will show a huge gap between the dew point and the temperature.
Yeah.
So is there an app or a source that you can think of, if you're thinking about just taking, well, of course, we're all mostly just going to Catalina, is there a source that you can think about that would help us to determine whether there could be fog on
I think you just have to see, did we have it last night? Usually you get it at night, as it cools down. There's nothing that I know of that you can actually look at, but be ready for it. And now with AIS, it's so much help. You know when the ships are coming, and if you have radar, you can see them coming. And if it's really foggy, maybe it's time to not go out or to go back inshore. So
nothing, no magic wand in terms of a forecast.
Not that I know of.
Other question I had real quick is that would you say with all those apps that you showed, Windy and Predict Wind and all that stuff, are most of them getting their data from NOAA?
Yeah, a NOAA or European.
So it's really pointless to try and look at a couple of them to get a general
They're
idea of what's going to be, because they're probably all getting their.
They're pretty close, although Europe is best in the Atlantic and GFS is best in the Pacific because we spend more time in there. Yeah.
Thank you.
Yes.
I have two questions. The first one is in performance sailing, when racing, you look out for patches on the water where the wind is building.
Yes.
How can you forecast, how can you see if there's a header or lift approaching? You really have to watch the other boats. There's no way you can just do it if looking out there and seeing. There's nothing that on the water that.
No, unless you know the area that well, that you sail there all the time. You say, "Oh, I know that, and we're going to be lifted or we're going to be headed." But no, I don't know.
Great, thank you. The other question I had is, you mentioned GFS. For this area here in Marina del Rey, also for performance sailing, what kind of weather model would you
Use
think is
HRRR is the best by far for this area because it's just a quarter mile between each of the barbs, and it's high resolution. It's 0.25. It only goes out 17 hours, so it's good for a day sail. But you can do it each day. You get up and run it for the day. And then after that, I would say NAM. It only goes out 2.5 days, but a lot closer barbs too.
The HRR updates like every hour, right?
Yeah, it's every hour, and it's very accurate.
Yeah.
We use that getting out of town when we're going to Hawaii because we often get that Catalina eddy, and you have no wind, and you're going, well, how are we going to get out past the island? Because the wind dies here, when the sun goes down. So if you don't get out past San Nicolas Island, you're there all night. So you got to figure out a way the first afternoon to get up past San Nicolas into the real wind. Yeah.
The race gets won there, or lost there.
Yes, yeah, you're right. Any other question? Yeah.
Yeah, I'm not sure I'm going to phrase this correctly, but earlier on in the discussion, you were mentioning, I think it was talking about the barometer readings as they were falling and raising conditions being more adverse or less adverse. I was wondering whether you were talking about more adverse for sailing conditions or just pleasant weather conditions or racing conditions?
It tells you what the fronts are doing and where is the highs and the lows. If it's going up, a high is coming in. That's good weather. If it's
that's what I mean, good
clear, yeah, and not much wind. And so if it goes down, a low is coming in, and you're probably going to get rain, but not a lot of wind, maybe a little more. But if the low comes in, then you're probably going to get a high with a lot of wind afterwards. So, yeah. Yes?
Have you ever sailed in the North Sea, which is part of the
I have sailed in the North Sea a few times. I could tell you this story. We built that 82-foot boat that we're sailing across the Atlantic on, Ondine, and it was built in Sturgeon Bay, Wisconsin, on Lake Michigan by Green Bay. We sailed that boat from Sturgeon Bay down the Lake Michigan, Lake Huron, Lake Erie, down the Welland Canal, Lake Ontario, down the St. Lawrence Seaway, the St. Lawrence River, St. Lawrence Seaway, across the Atlantic, over Scotland, up across the North Sea to Oslo, Norway. Sailed the King of Norway, who was he was an Olympic gold medalist in 1928 in sailing, and we sailed with him. He's a friend of the owners. We went down, did the Fastnet race from England to Ireland to England, went into the Med, did the Maxi World Championships in Sardinia, Italy. Then we went back and Mallorca, Gibraltar, up over the Azores, up over Bermuda, and then we got hit by that hurricane I was talking about. We lost our rudder. We broke the whole boat. It went over, we rolled, broke our mast. We sat and we fixed it, and we called the owner, and he was in New York. And we said, "What do you want us to do? Bring the boat to New York?" And he said, "No, take it back to Sturgeon Bay, Wisconsin. They got to fix it." So then we had to go up the St. Lawrence River, St. Lawrence Seaway, across the Lake Ontario, up the Welland Canal into the Lake Erie, and now there's a blizzard. It's November now. Oh. We're in a blizzard and it's snowing. Go across Lake Erie, across Lake Huron, Straits of Mackinac, into Sturgeon Bay, and got there, and it was iced over. So we're trying to get into Palmer Johnson, and it's ice. So we call up the harbor master and say, "Can you send a boat out and break the ice for us? You know, we've just come from Europe." And the guy says, "Okay." And they brought a boat out, and we took it in, cleaned it all up, tied it up. We're still all wearing our foul weather gear, our harnesses, our sea boots. We walked across the street to the nearest pub, and it had a little bar with a brass rail. We all hooked our harnesses around the brass rail, and we said, "Bartender, there's a rum squall coming." So that's the story. Yes?
Have you ever used your radar on your chart plotter to look at a storm?
Yes. Yeah, we use it to look at squalls. You can see squalls on it, yeah.
Yeah, just like you get the same picture that you see on television.
Yes, yeah. Yeah, I use them. Yes?
Yeah, I was wondering if any boats are using Starlink internet from Elon Musk.
They're going to be. Right now it's Iridium. They have 48 satellites up there, but they're talking about switching over to it, yeah, because there's so many. Pretty soon the whole sky is going to be full of satellites.
I got a question over here.
Yes?
So I have a question for a member that's not able to be here, but they just want to ask an overview of them. So they said they're a pilot, and they spend a lot of time learning about detailed weather forecasting and the importance of local gurus and microclimates.
Yes.
They found that a lot of their techniques for forecasting do not provide the same level of accuracy for marine forecasts.
Mm-hmm.
Why do you believe that there is more uncertainty in marine forecasts than land forecasts? And what suggestions do you have to improve the prediction?
Well, it's probably because there aren't as many sites out there sending in the information. It's just ships, and land, you got it everywhere, you know, all the time. So that would be my guess. It's getting better and better, though. I've been watching it for 40 years, and yeah.
It's all about data.
Yeah, true. Yes?
Mike, had any fun with it? Any stories to tell?
I'm still racing. I'm still delivering boats. In fact, take one of my cards. I do deliveries all the time. I'm always looking for a delivery crew. I just came back from Mexico. I just came back from San Diego. I'm going to Santa Barbara, and then I'm going up to San Francisco. And just lots and lots of sailing.
I think I have almost sailed to the moon and back, over 400,000 miles. I may have more miles than anyone else in the world. Yeah.
The question is lightning, actually. It's lightning. Lightning.
Oh yeah, lightning's scary, and there isn't much you can do about it. You don't know where it's going to come. What we do is, if it's starting to go around, especially you see it a lot in the Caribbean, you get a lot of lightning, and we just start unplugging everything and taking our good stuff and sticking it in the oven or in the microwave and just try and protect it. You can't really fight it, and all you can try and do is survive it. Yeah. I've never been hit. I've had it fairly close, but never been hit. Fortunate, yeah.
You don't have a lot of hair to stand up.
That's why it's that's why I have no hair. Right.
How about hove to? What's your position?
I hove to all the time. I love hoving to, and I love fore-reaching. When you get into big winds, just put up your storm trysail and slowly, 4 or 5 knots, slowly go across the waves. Hove to, you just crank the boat over, leave your jib on the other side, bring your main in until you're going off about 60 to 90 degrees off the wind, and you're going 2 knots, and it's calm. Even in 50, 60 knots of wind, hoving to makes it calm. Yeah, it works. And you have to practice for your boat, because every boat's a little different. Well, thank you all. It was very nice meeting you.